Assalamu alaikum students. Today we start exercise 2.3. Now theorem on differentiation. First we find derivative of a constant function. dy by dx shows derivation with respect to x. We prove in first example of 2.1 derivative of a constant is equal to 0. And also in example, if we have a variable with power n, then its derivative is we multiply with the same power and subtract 1 from its power. And third derivation is constant multiplied by the variable. We apply the rule of definition. We change the variable y plus delta y, x plus delta x, then subtract these values, divide by delta x and taking limit, and at the end we find the answer constant and derivative of variable. In question we have a constant with variable and derivative of constant and derivative of variable, and constant remains same. If you have only constant, derivative is 0, but if a constant with a variable, then the answer is constant and derivative of variable. Now here we have example 3x and power 4 by 3. When we take its derivative d by dx, it means we move the power, multiply with the variable and subtract 1 from its value, and constant 3 remains same, and simplify these values. Now the derivative of sum or difference of functions. We have two functions f and g. If they are in sum and subtraction form, then their derivative is equal to derivative of the individuals with the same sign. We also prove this theorem by the same method of by definition. We replace variable with delta x and then subtract these values, divide by delta x and taking limit. Now here we have a series and we find its derivative. When we differentiate this equation with respect to x, we apply d over dx to both sides. dy dx is an operator which differentiate with respect to the variable, and first term is x raised to power 4 and its derivative is n x n minus 1. N is 4, so it becomes 4x 4 minus 1. In second bracket, second term, it is x cube 3x 3 minus 1. In third, 2x 2 minus 1. In fourth, only x, it means its power is 1, 1x 1 minus 1, and its derivative become 1. And in last bracket we have a constant term 5 and its derivative is 0, and then we simplify these values, and on left hand side y, derivative of y is dy by dx. Now in this example we first multiply these two brackets and then differentiate with respect to x. We apply d over dx to both sides. First term and its power is 5, 5x 5 minus 1. Second term x cube 3x 3 minus 1. Third term x square 2x 2 minus 1. And last is 35, its derivative is 0. again we have two bracket. Now we simplify these two bracket by multiplying, and here we simplify and then multiply, but you can multiply direct these two values. When two variable multiply with same base, then their power will be add. Now at the end, when we simplify these two values, here we simplify like in second bracket we common square root x, because single x is equal to 2 square root x. Then in second phase we multiply two brackets a plus b and a minus b, a square minus b square, and then again we multiply by 2 square root x. Add the powers. When square root x multiplied by x, the power of x is 1 and power of x square root is 1 by 2. It becomes 3 by 2. Then differentiate n minus 1. Now derivative of a product function, we have product f of x and g of x, and its derivative is equal to derivative of the first function, and second remains same, and first is same and derivative of the second. Now we prove this formula by using the definition rule. We replace x by delta x plus delta x, then subtract these two values, subtracting and adding in this equation f of x and g x plus delta x, and then taking common and arrange these values. Now we divide by delta x. Now taking limit, in left hand side we become phi dash of x, and in second we change the first bracket into f dash of x, and in second bracket g dash of x. Now if you have two functions in product, their derivatives, derivative of first and second remain same, plus first remains same and derivative of second. This also apply on the function if we have three function in product form. Again we have the same example, and now we apply the product rule. We have two brackets, one is f and second is g. And when we apply differentiation, we apply d by dx in first bracket, and then we apply d by dx on the second bracket, but write in the same way. Derivative of the first, second is same, plus first is same and derivative of the second. When we apply d by dx in first bracket, its power is 1 by 2. It becomes 1 over 2 x 1 over 2 minus 1, and derivative of 1 is 0. And when we apply d by dx on second bracket, derivative of x is 1 and derivative of square root x is, its power is 1 by 2. 1 by 2, 1 by 2 minus 1. And then we simplify. Now we have quotient rule. If we have function in fraction form, now its formula is f of x over g of x. It becomes the same like product rule, but here we have negative sign between them, and denominator with square. derivative of the first numerator, denominator is same, minus numerator is same, and derivative of the denominator, and divided by the square of denominator. But we prove here, we also again by definition, x by x plus delta x. Then we subtract these values taking LCM, and we add and subtract f of x and g of x in numerator, and then we arrange these values. From first two values we common gx, and second two values we common f of x, and divide by delta x. And then taking limit, we divide by delta x, and then taking limit, and first bracket becomes f dash of x and second is g dash of x. And now remember this formula, derivative of the numerator, denominator is same, minus numerator is same, and derivative of denominator, and divide by the square of denominator. Now the reciprocal rule, if we have a constant on numerator and denominator with variable, its answer is minus d by dx of the denominator and square of denominator. Using the product rule, f of x dot 1 over g of x. We also use product rule to prove the formula. In product rule, we derive the first plus derivative of the second. Derivative of the first is f dash of x, and derivative of the second is minus derivative of the function over its square, and then taking LCM. But the first proof is more easy than this. Now, an example, we first simplify these values. In second bracket in numerator, we can apply the formula a cube minus b cube. X 3 by 2, when we write it whole cube, it becomes x square root x cube, and on 1 we can write 3, and the second bracket becomes a minus b, a square plus b square plus ab. We multiply first two brackets, or we cut the numerator square root x minus 1 by the denominator. Then we multiply the values and we obtain a series, and then we differentiate these values and we apply the same rule. In first term, power minus 1, second term 2x, derivative of x is 1. In third term, its power is 1 by 2, 1 by 2, 1 by 2 minus 1, and last term 1, its derivative is 0. Now again, same example, we apply formula cube a cube minus b cube in the numerator, and in denominator we common square root x because x raised to power 3 by 2 can also write as x square root x, and we common square root x, and here we have the value at the end x plus square root x plus 1 over square root x, and we apply the quotient rule. We leave the denominator and derivative of the numerator minus numerator derivative of the denominator, and square of the denominator, and then simplify. Now here we have example. The numerator is equal to f of x and denominator is equal to g of x. We take their differentiate. In f of x, its power is 2x cube. Now when we take derivative, x cube is equal to 3x square, and x square is 2x1, and derivative of 5 is 0, and derivative of g of x square plus 1, derivative of x square is 2x, and derivative of 1 is 0. Now we put these values in this formula. F dash of x is equal to 6x square minus 6x, g of x square plus 1, and then f of x 2x cube plus 3x square plus 5, and g dash of x is equal to 2x. We multiply the numerators and then simplify this. Okay student, today's formulas are: derivative of a constant is 0, derivative of x is 1, and derivative of x raised to power n is n x n minus 1, and then product rule. If you have a two function f and g, derivative of f multiplied by g plus derivative of g multiplied by f, and then quotient rule. Here we have its formula. F dash of x means derivative of numerator multiplied by the denominator minus numerator multiplied by the derivative of denominator and divided by the square of denominator. These 5 formulas for today. Learn these formulas and apply on these examples. I hope you understand. Thank you and Jazakallah.